So, quickly, because we have a very short time, what we want to do before we get into the big calculations is understand the statistics. We should understand better the statistics we are used to. I'm sure everyone here from grade 5 or I think 6 have heard of mean, median, and mode, right? But most of us only understand that we just calculate. What does it represent? We don't know. If you have a set of data and it goes on up to maybe here, these statistics, the mean, median, and the mode, or averages, are used to measure where is the center of this distribution. Okay? The center of that distribution. Now, we know in the past, of course, that mean is addition of everything divided by how many, isn't it? So basically, of course, now you are used to sigma notation. I'm just rushing through this because it's not that strange. Addition of all the data, so we say summation x divided by n, something like that. And summation x means maybe I from 1 to n. There are n of them in that regard. Mean is denoted by x bar. So that might be a new notation for us, using x bar. But I'm going to write it down, no worries. Divided by x bar. So this is the mean of the distribution. So you'll be used to something like x bar is equal to summation f of x at some point divided by summation f. This is when you have a frequency distribution table. We'll talk about that. It's just an extension of this, really. I'll explain when the time comes, so don't bother too much. Then also there is the median. Do you remember what median is? What is it?
Count from
Halfway, right? So to find the median, you have to first consider the order, either an ascending or descending, isn't it? Then you take the one at the center of the distribution. Okay, you see, it also tells you where is the center likely to be. Understand? Then we have the mode. The mode says, oh, yeah. By the way, on median, sometimes you have odd number of, if n is odd, then you have something like 11, right? Then you can pinpoint only one value at the middle. Understood? But if n is like 12, then there are two things at the center. Then you have to consider their own arithmetic mean as well. You remember that? Aha. So that's that for median. So for median, basically it is n plus 1. Always remember this. I'm going to write that in summary. N plus 1 item or value. This is the position of the median. So that if n is an odd number, say 7. If you have 1 to 7, number 4 is your median. Right? And that 4 is 7 plus 1 divided by 2. So this is not the median, this is the position of the median. Understood? And if it is even also, it doesn't matter. So take 4 numbers. There will be 1 here, 1 here, 1 here, 1 here. The median is in the position 2.5. Isn't it? Which is the arithmetic mean of these two. How do you get 2.5 from 4? 4 plus 1 divided by 2. So this is the position of median in any distribution. Okay? And for the mode, do we remember what mode is?
the value that comes up the most.
That comes up the most, the one with the highest frequency. That does not require any calculation, just observation. So for mode, you shouldn't bother yourself trying to arrange. It's just a waste of your time. By inspection, you can always know. And if you are lucky to have a frequency distribution table, you just consider the frequency that has the highest number and locate the point that owns that frequency. Understand? So these three, if you read some other literature, textbooks, they are called averages. So I remember when I was learning, when the teacher asked us to find average, everybody finds this. You have to be specific. So in standard exam, you to be specified. Are you talking about the mean, the median, or the mode? Because any of them could be the average. Because any of them can tell you around where is the center of the data. Isn't that the whole point of average? Do you understand that? So don't mistakenly just say average means this. You have to be specific which one. In some textbook, you see average and in bracket mean. Because if a candidate decides to write median, you cannot penalize the candidate because you said average. Just like you telling me, oh, the center of the data. The center of the data may not necessarily mean the mean. It depends on the scenario. Are you getting my point? So that is the whole summary of what I want to remind you of. Now, by the way, I forgot to mention, some distribution can have more than one mode. Krista, what is funny? You're beginning to laugh. It shows that you are distracted by something else. What is it? Is it branding? Shall we not start this now? Thank you. Some distribution might have one mode, some might have two modes. In fact, what says you cannot have a distribution with three modes. So you'll be hearing words like unimodal distribution, bimodal distribution, trimodal distribution. Just like mono, bi, tri, like 1, 2, 3, basically. So if I have 1, 2, 2, 1, 3, 4, or let's say one like this, what is the mode of this distribution? 2. But if I have this, 1 and 2. So this is a bimodal distribution. There are two modes. It's possible. And that is what it says. Okay? So if you are reading your textbook, don't get confused. When you have a district data, your mean is a value, your median is going to be a single number, your mode might be 1 or 2 numbers, at least for now, right? But when you have a continuous data, your mean is not exact, your mean is an approximation. Because it's continuous data. Remember, the values are not exact. The values are a range of values. So when we calculate, you'll be saying something like estimate the mean. What you are getting is an estimate, it's not the actual mean. Do you understand that? And in that case, you don't talk about the median. Of course, there are ways we get approximation of approximate median and approximate mode, but not for this level. The last time I did that was my Polytechnic days, around 2003, 2004. So you don't need to worry about that, it's not in your syllabus. But rather we talk about modal class, median class. Okay, the mean is somewhere in this range. What is that range? Oh, the range is 40 to 50. We don't need to get an approximation of what that median, I mean. We don't need to get an approximation of what it is for our level right now. But if you get to the university, you are doing some statistics, and the professor is talking about that, don't say, oh no, Mr. Daniel told me rubbish. No, this is what you should think of right now. That is why we are not going beyond that. It's a one complex formula, but very interesting as well. Anyways, now, of course, you remember this. Sum of all the data divided by how many they are. Okay? That represents the mean of sample, and this mean represents the mean of population. We are not calculating mean today. Like the complex ones, so we are not going to worry. Median is halfway of the data, and mode is how many we have. Okay. Now, I sent you a picture on WeChat of the calculator steps. Maybe we can project it also. Because I'm going to want you to try to use your calculator to calculate this mean. This is not the question I gave you. Okay, is that, check your paper. Is the first one require calculator? Yeah, one of them require calculator, which is number 3. Can you see that? Number 3 in this worksheet. It says use technology. So let's try to use the calculator instruction to calculate the mean of this data. Let's try to follow this instruction and get used to this. I sent this picture to you also. To find the mean and median and mode of this data, select statistics, enter the data into list 1, press F6 until the graph icon on the left is in the left, blah, blah, blah. Press calculate, then press set, and you will see the following screen. So the mean is the X bar, the median is MED that you see, and the mode is just MOD. N will tell you how many data you input. So if your N is not the same as the number of data, then there's something wrong. So in your case, you can check how many data I put in that paper, and let's compare answers, making sure everybody is doing the same thing. I hope you are doing it on that table as well. Okay. Did I see you putting in 2 columns?
6.
You don't have any business with L2. What are you doing with list 2? Are we using the same company? Oh, this is CG50. This is 9860. Who has done it? Because this instruction is for CG50. Did you get it?
I did a different.
No. This is what I'm talking about. I'm talking about the answer in your worksheet. The question in your worksheet. Did you get it also?
I got numbers.
1, 2, 1. This one. 1. These aren't
Yeah.
exit.
Just put it in there. Yeah. List 1. 13.
Minus. Wait.
What? Yeah, we're trying to figure that out.
39.7.
Say that again?
39.7.
39.7. Yeah, approximately. Yeah, just use 6.5 because it's terminating decimal, right?
Median is. Wait, what is this?
What do you get for your median?
Wait, which one is median?
I was just like,
Median is 40.5.
Confirm, please.
Mode is 41, 43, 48. 3 modes.
Can we get confirmation, please?
I got one number 1.
Okay, I'm not using this number.
39.7.
39.7.
So let's take note of what Brandon got. Your mean is what?
39.7.
39.7 approximately? Okay,
It's
6.5.
actually, I think it's 37. I think
think
Calista
it is
got that
7.
wrong.
It's just 7.
I think it's just 7.
Okay, median.
40.5. Is it 40.5? Median is 40.5.
40.5.
40.5. Confirm that. Mode?
41, 43, and 48.
Wait, there are multiple modes?
3.
3 modes.
3
So
modes.
that's a trimodal distribution. 41, 43, and
48.
48. Please confirm that, everyone.
Yeah.
So fill in the table that you have in that worksheet. All right, fill in the table. Is that for the bus?
Yeah, that's only the bus.
Okay, now do the same for the tram. Do the same for the tram.
Did you guys get 40? What did you get? 40.06.
49.06.
Yeah, 49.06.
And then median is 45.
Yeah.
49.
Yeah, okay.
You're supposed to work with only one list. List 1. You don't have any. Does it go to list 2 automatically?
No, you have to change.
You have to,
Yeah,
you have to change it.
What I mean, do you have any business with list 2?
If you type it in list 2, then you need to change the set.
Like you see like the second box there. Like
Yeah.
you change the first.
So what I'm saying is, so basically, the instructions say list 1, right?
Yeah.
So don't put anything in list 2 then.
Yeah.
Yeah.
The way you press like. Okay, that looks fascinating. Started? Now, we're going to think of the question that follows. Okay, maybe we wait for others to sort. Confirm, 87 point something.
8.
80?
47 is a lot.
What happened?
40.
Uh-oh.
What is the median?
Let's delete that.
49.
Yeah, okay.
50. Oh my god, you put 688. She's too generous. Instead of 68, she put 688. You're so nice.
A lot of people.
You are a good sister Christmas.
Imagine working from the back.
So what's the mean? 49.06 something?
Yeah.
Good, so 49.1.
Thanks.
But basically, we are talking about the number of passengers, right? So we can't have decimal. Isn't it? We're talking about number of passengers, so we can't have decimal. So our mean should be like, say, 40 and 49. Then our median should be like, say, 41 and 49. Understand? Because we can't have decimal. You can't say 45.2 people came to my bus today. Like, where does the 0.2 come from? Just the egg? Okay, so now look at the next question. It says, which of the methods, which method of transportation do you think is more popular?
Tram.
Tram, why?
Both the median and mode are higher.
Both the median and mode are higher.
Median.
Mean.
Media is higher.
Interesting. What has popularity got to do with number of stuff? Let's see. How many, look at the first one. What is this data about? The number of what? Passengers. The number of passengers on each trip, isn't it? Whether there are, many people or not, there's always a trip, isn't it? So the popularity, well, fine, we can talk about the number of passengers, but even look at the number of trips. How many trips do you have for the bus?
20 something.
20. What about the tram?
16? I don't know. With 4 less.
That's 16, isn't it? The bus goes 20 times the day, the tram goes just 16 times. It's obvious. The bus is more popular. Even though the other one has more data, more mean or whatever you've calculated, but that doesn't mean it's more popular. Maybe people are going into that because of the cost or whatever reason. You understand my point? So look at the number of trips. Like if the government is going to allocate more trips to something, it's going to be based on popularity, based on demand. If less people are going by bus in Macau, there will be fewer buses to go on the trip, isn't it? During the pandemic and there were lockdowns, did anyone notice that the public bus has very few working in a day? Based on demand, but it wasn't popular, so there will be no many trips. And you might see a bus going, left, right, and center with 0 people inside. Do you understand? So the number of people being taken doesn't really determine in this case. Am I making sense?
Yes.
So with that, we cannot say that the tram is popular because the average number of passengers is this. Okay? Remember, we don't even know the tickets, how much the ticket costs. So many factors will come in play here. So the most important reason will be how many trips do you have in a day. And the bus has so many trips. Okay? And there's no restriction about, until the passenger is filled up before we can move, right? That is why there is variation in number of passengers going on each trip. But the number of trips will tell you how many people, how much this is popular among the community. Understand? So that is one thing. With that, I want us to deviate a bit into some properties here. Or maybe before we go into the properties, there is this investigation here that I want you to do. This is something you can always sort out on your own, so we're not going to waste too much time on that. Remember what we talked about outliers the last time, right? Can somebody remember what that means?
It's when it doesn't follow the rest of the data.
It's like always standing on its own, right? So is either standing on its own towards the right or towards the left, isn't it? If it is towards the right, it means it is very much higher than the maximum, the original maximum number. Or if it is towards the left, it is so small, like smaller than most of them, isn't it? So now this investigation captures the effects of outlier on these statistics we have just talked about. Okay, the reason I want to mention it is because of these properties. Okay, so let's see, rather than just reading these properties that are printed, I want you to quickly work on either your scrap paper or your notebook or whatever, or even you can use the calculator. Maybe the calculator will be faster. Let's calculate the mean, median, and mode of this data, and let's write it down. Maybe we do it together to save time. So for this data, 4, 5, maybe I can enlarge that. So put it in your calculator and tell me the mean, median, and the mode.
6.8.
Say that again.
6.8.
6.8, median. 6.1, and mode. 6. Now,
No,
Six
median
point.
should. 6.
oh, are you arranging in this order? Talk to me. Are you arranging in this order? Okay, so let's put it that way. Mode, then median.
Also, your mean
Mode is
60.
6.
I thought you said 6.8.
Mode is 6.
Mode is 6.
Median is 6.
Come on, guys. What is the mean? What is the mean?
6.8.
6.8. What is the mode?
6.
6. What is the median?
6.5.
6.5. Like that?
Yeah.
Okay, great. The next thing says, suppose we introduce 100. 100 is definitely an outlier, isn't it? Because it's like extreme, much more greater, okay, than the rest of the data. So introduce 100. Then what is your mean?
15.
When you include 100 now, your mean is
15.3.
15.3. What is your mode?
6.
6. What is your median?
7.
7. The next thing says, comment on the effect of the extreme value. Extreme value is your outlier. Understand? It's extreme. It's not the greatest value. The greatest one here is just 10. But the extreme is like, come on, that is way out of line. You can see we are just a bunch of 4 to 10-year-old. Why do you have to bring a grandpa in? That's so extreme, isn't it? Now, comment on the effect of the extreme has on the mean. Does it have any effect on the mean?
Yes.
What does it have?
Basically doubles
Pretty
it.
severe.
It's like so huge. It might even be more than double. It's more than double, isn't it?
Yes.
It's more than double. So yes, it has a very drastic effect on the mean. What about the mode?
No change.
Okay? What about the median?
Small change.
Very minute change. Can somebody tell me what might happen if the additional data is, say, a very small number? For example, let's say these are 40s and 50s. Okay? Instead of 4, 5, 6, up to that. Let's say these are 40s, 50s, up to 90s. And this is 1,000. The extreme here is 1,000. Of course, the same will happen. But rather than 40, let's say the extreme on the other side is 1. What do you think might happen? What do you think will happen to this mean?
It'll go back to that value. Or similar to, closer to that.
They're not listening. Forget about this one. Let's say they are in their 40s. These are 10s. But the extreme is now 1. Okay, let's try it. Take this as 40, 50, 60, 60, like that. Okay? Do that. Make them 10s. This will be 100. So they are close to themselves, isn't it? See what happens when you include 1. 1 is an extreme value, isn't it? What do you get, Krista?
61.9.
Before you included the 1, what is your mean? Sorry, before you included the extreme value, let's see what the mean is, the mode is, and what the median is. Before you include 1.
Do we include 1,000 as well?
Don't include 1 yet. Tell me these numbers, but make sure they are in tens, like 40, 50, something. What is that?
68.
68. What about the mode?
60.
60. What about median?
65.
65. Now include 1. Include 1.
61.9.
61.9. What about the mode?
60.
What about the median?
60.
60 also.
Yes.
Now, let's include 1,000, the extreme on the other end. Remove 1, of course. Remove 1. Or just edit 1 and change it to 1,000.
152.
122.
152.
152.
152.
0.7.
What? 0.7. Okay.
60.
60. Very stubborn.
70.
70. Now you can see a true picture. What happens when you include the extreme data? Does it affect the mean? Does it affect the mode?
No.
You know why it can never affect the mode? The mode is the one with the highest frequency. The extreme value cannot be equal to the mode. Otherwise, it's not extreme anymore. If your mode is 60 and you call someone extreme, it can never be in the 60. Because it is called extreme in the first instance because it's far away from the rest of them. So your mode will never change. But your median can change because the position of the center value might change, will definitely change. If there was only 1 at the middle, then you have to consider an average because there's an additional data either at the end or on this side. So there will be a slight change in your median, but it's still going to be within the neighborhood of the initial information. Do you understand that? So the extreme value affect the mean and never affect the mode, but slightly, like something negligible when it comes to the median. Understand that? And that is the effect of outlier in a distribution. Okay? So, let's look at this paper. It's also on the board. For the mode, this because you need to understand this to be able to know which statistics to use. And that is the last thing. And that is what you have on the second page of the worksheet. The mode gives the most what? Value. Okay. I think I rearrange it. Mean median mode. We are used to mean median mode. So I arrange it in terms of mean median mode. Let's go to the mean first. It's commonly used and easy to understand. Even the weather forecast will say, oh, on the average of, they are mostly talking about the mean. If you are to do your data, whatever in school also, oh, the average score for the term is mostly arithmetic mean. So when people talk about average, most of the time they refer to the mean. So yes, that is commonly used and it's easy to understand. The mean takes all values into account. No one is left behind. If there's a small value, it's going to affect everyone, isn't it? If there's a big value, it's going to affect everyone also. So yes, everyone has a say. The mean is affected by the extreme value. We just saw that in our own little experiment. Okay? Let's go to the second one, which is the median. Median gives you halfway of the data. This we already know. Okay? Median takes only the middle values into account. There might be only one value and there might be two values, isn't it? So median only affects the middle values and takes them only into account. So what happened at the edge is not your business if you are using median. So which means if the information you are trying to interpret has no business with the extreme, then median is your best bet. Do you understand that? And it's not affected by extreme value. We already talked about that. Then the mode. The mode gives the most usual value. Oh, what is more common? Oh, what is the popular whatever? Oh, what is the popular demand? Something like that. Only takes the common values into account, and of course is not affected by extreme value. Now let's see some example. I will use the example in your book. Look at the board, please. A shoe store is investigating the sizes of shoes to be sold over 1 month. Okay, sold over 1 month. Of course, our shoe size is immaterial here. The average, is immaterial here. We're talking about the shoe size. You own a shoe store. You're thinking of restock. You have no business with the mean shoe size. Because your customer wouldn't come today and say, I need size 7.2. Do you understand that? But if you consider the mode, what size is so popular among the people of Taipa? Do you understand? Then you can say, okay, in that case, I need to restock more of size 7 because, oh, people with size 7 shop here a lot or something like that. Or people in this neighborhood buy this a lot. Okay? You can't be talking about the arithmetic mean in that regard because that could even be decimal. So, dimension size is not useful since it's probably